talking about. Okay. So we also said that we can add two polynomial functions. Okay. And the degree, if my degree of P of S is greater than the degree of Q of S, then the degree of the summation will be M. That is the degree of P of S. And then we can also multiply two polynomial functions if I have P and then Q. And the degree of P of S is M and the degree of Q of S is N. Then when I multiply the two, the degree will be M plus N. Then we also spoke about the zeros. That suppose S equal to A is a zero of P of S plus 0. Then we said that we'll explain this one later. Then we also spoke about long division, that we can divide a polynomial function P of S by another function D of S. And we're going to get another polynomial Q of S with remainder R of S. So my P of S can be written as D of S, Q of S plus R of S, where the degree of D of S is greater than 0 and degree of R of S is less than the degree of D of S. And the polynomial function Q of S is called the quotient, and then D of S is called the divisor, and R is called the remainder. So example, if I want to find the remainder for P of S is equal to S to the power 3 plus 4S squared minus 2S plus 3, divided by D of S, which is 2x squared minus 1. So to divide this using long division, we know that this should be under the this sign, and then we'll have the divisor here. So we'll have S to the power 3 divided by 2x squared. So I'll have something like this. X to the power 3 divided by 2x squared. And we can see that by indices, 2 will cancel. I'll be left with 1. So I'll have x over 2. Okay. So the first one, I'm going to get 1 over 2x. Okay. Then what we do is, after you have divided the first term by this term, you go back and multiply this by this. So you divide the 2s, you multiply the 2s squared by the half x, which will give you s cubed. Then after that, you multiply the negative 1, this negative 1, by this half, which will give you negative 1 over 2x. Okay, so let's see how we do it. So I have the function s cubed. This is 2s squared minus 1. It is s cubed plus 4s squared minus 2s plus 3 minus 2x plus 3. Please, am I online?
Yes, please. Madam. You're allowed.
Yes, madam. Okay. So first you divide this term, the first term, by this. And as I did, when you divide this x to the power 3 by 2x squared, you are going to get half x. Then after that, you multiply the 2x squared by the half x. So when you do that, you're going to get s cubed. Then you multiply the negative 1 by the half x, and this will give you negative half x. So I wrote it under the 2x because they are of the same power. So it means that the middle here is 0x squared. So I'll bring negative sign here, then I'll subtract it from this. So when I subtract s cubed from x cubed, I'm going to get 0. Then I'll subtract 0 x squared from 4x squared. This will give me plus 4x squared. Then I'll subtract, so this one is, I'll subtract negative half x from negative 2x. So this is negative 2x minus minus. So minus minus will give me 2. 2 plus half x. And what do I get for this? Minus 2x plus half x is what?
Negative 3x also.
You get
Negative
1.5 minus 1.5.
Which is the same as somebody
Negative
says.
1.5.
Which
3
is the
over 2.
same
Negative
as
3
in
over
a
2.
improper fraction, negative 3 on 2. Okay, so we'll go here, then we'll have negative 3 on 2x. So after that, this 2x will have to divide this one too. So when I divide 4x squared by 2x, what do I get? 2x squared, what do I get?
Two x squared.
You get 2.
Please,
2.
you get 2. So I have plus 2 here. Okay, thank you. I have plus 2 here. I'll bring my negative and then multiply the 2x squared by the 2. Okay, so when I multiply, let me write it under this. Okay, so I have negative, then I multiply this 2x squared by the 2. So what do I get? I have 2x squared. Then I'll multiply my negative 1 by the 2. Okay, so this side, after that, I remember I have 3 here. So I'll multiply the negative 1 by the
Madam,
the 2 times
when
the
you
2, it will be 4x
multiply the 2
squared.
by the 2x squared,
it
you
will be
get
4,
4x
it will be
squared.
4, yeah.
4x squared.
It will be 4x squared. Thank you. So I have 4x
Yeah,
squared.
4x squared.
Okay. So negative 1 multiply, you have negative 2. So this side is seen as negative plus 0x. So I will subtract. When I subtract 4x squared from this will give me 0. Then I subtract 0 from this will give me minus 3 on 2x. Then I subtract negative 2 from 3. This will give me plus 5. Okay. You can see that for this one, 3 on 2x, the 2x squared cannot go or divide it. So it means that the function p of x. Okay, so let me just write p of x divided by d of x. D of x is my divisor. It's giving us, we are going to get, when we divided, we had 1 over 2x plus 2, and this is the remainder. So the remainder minus 3 on 2x plus 5. And this one is divided by that. Okay, so divided by d of x. So if I want to write it in another form, then I can write it as p of x is equal to 1 over 2x plus 2 in a bracket, then times my divisor, which is 2x squared minus 1, all minus 3 on 2 plus 5. We were told that we can write the function as the divisor times the quotient plus the remainder. So p of x is equal to the divisor times the quotient plus the remainder. Okay, so it's the same thing. We decided to write the quotient times the divisor minus remainder. So that's what we're going to get. Is it plus remainder, but ours is negative. Okay, so this is the remainder. It's minus 3 on 2x plus 5. So when we write it, we are going to get the divisor times the quotient, then plus our remainder, and our remainder is minus 3 on 2x plus 5. Okay, there's a hand, Michael. You can talk. Michael, your hand is up.
Yeah, please, madam. What I'm asking is, you divided by the, what do you call it? I did not get the process well. So if you go over it again for me, please. Hello, madam.
Yes. Please, someone is called. Yeah, I'm here.
Yeah. What I'm saying is the process, how you go through, if you can go over it again. Because at a certain point, as if I get lost somewhere. When we are doing
Like,
the
have you
explanation on
done
the
this?
board.
Have you done this before?
Yes, before. No, madam. Sorry, please.
You've not done long division, dividing polynomial functions before.
Yes, madam.
Madam, please, we have done it, but we use different approach to do it. We didn't use this one.
What approach? What approach did you use?
Madam, we take the first, what do we call it? The first degree, and we divide it to a divisor, the first one. After you have finished dividing it, you subtract it from the, what do you call it? I've forgotten the name. You do it.
Is it different from what? Is it different? Is it different from what I've done here?
It's different from this one, but at the end of the day, you get the same answer.
Is it a synthetic approach?
I think that's it.
So you will not bring the xxx, you will just bring the values.
Yes.
Is it that one?
Yeah, that's one. I think we used
where
almost
did
2
you,
or 3. Madam, last
where did
block.
you do that?
Madam, the last block, we just did the last. Yeah.
That was algebra thinking, right? Yeah, something like, yeah.
Madam, but we are doing mathematics ICT, so it's mathematics computing or something.
Computing the night.
Yeah.
It's maths for computing. That is the name. Mathematics for computing. But we also did this one, just that we concentrated on the synthetic since that was the easiest one. We also did this one too.
Okay, so let's continue. Okay, so we want to divide this function by this function. So what you do is you take the first function, that is x to the power 3, and you divide it by the 2x squared. When you do that, you're going to get, I think I wrote it, so x to the power 3 over 2x squared. This one, this by indices, this will divide, take 2 of this. So I'll be left with x over 2. So that's the reason why I have half x. So when I divide this by this, I'm going to get half x. Then after that, I will multiply this by this. So when I multiply 2x squared by half x, it will give me x to the power 3. So I'll bring it under the x to the power 3. Then you will see that I will multiply the -1 by the half x, and this will give me negative half x. So I'll bring the negative half x under the function, under the x function, and this is, I have 2x, so I'll write it under the 2x. This means that there's no term, when I multiply, there's no term in x to the power 2. So that is 0x to the power 2. Then after that, I'll put this in a bracket. Then I'll bring negative. When I bring negative, it means that I'm subtracting what is in this bracket from what is up here. So when I subtract this x to the power 3 from x to the power 3, it will give me 0. Then I'll subtract 0x squared from 4x squared, which will give me 4x squared. Then I'll subtract, okay, so this minus, so this is positive. So I will add half x to negative 2x. And I think your people did it for me. They said that when I add half x to negative 2x, I'm going to get negative 3 on 2x. Then I'll write the remaining function. The remaining function is 3, so I'll bring the 3. So after that, I'll just bring this line here. Then I will divide the 4x by the 2x squared. And when we did it, your people did it. You did it for me. So when you divide 4x squared by 2x squared, you are going to get 2. So that's how come we have 2 here. So I'll bring my 2 here. Then I will multiply the 2x squared by the 2. So I'll open a bracket. I'll write the multiplication of 2x squared by 2, which is 4x squared. Then plus, I will multiply the negative half by the 3, which will give me negative 2. So I'll bring it under the constant, negative 2. So this means that there's no x, any function or anything in x. So I'll write plus 0x. Then I'll bring the negative sign and then start subtracting. So I will subtract 4x squared from 4x squared, which will give me 0. Then I'll subtract 0 from 3 on 2x, which will give me negative 3 on 2x. So I have negative 3 on 2. Then I'll subtract negative 2, which is negative is 2, positive. So I'll add positive 2 to 3, which will give me 5. Then you can see that this is x to the power 2. This is only x. So it means that I cannot divide the function by this again. So this is my remainder. What I have here is my remainder. And the one up here is called the quotient. The one up here is called the quotient. This is called the divisor. And what is remaining is what I call remainder. So from the theory, I say that P of x divided by D of x is equal to the quotient minus the remainder divided by the divisor. Or in other words, I will write P of x is equal to, so I write my quotient times the divisor minus my remainder. So that is it. Are you okay? Am I online?
Yes, please.
Yes, please, you're online. Okay, so note from the example that the long division amounts to a successful multiplication and subtraction and terminates when the condition that the degree of R of x is less than D of x is met. Equation 4.1 is what we refer to as the remainder theory. In this example, if R of x is equal to 0, then P of x is equal to D of x times Q of x. In this case, P of x is said to be divisible by D of x, or D of x is a factor of Q of x, and Q of x is also a factor of P of x. Q of x is then said to be factorized into its factors. If D of x is linear, then this case is stated in another theory that follows. Okay, so we are talking about what we call the factor theory. So factor theory says that, okay, so what I just read says that now if I have a function, if I have a function P of x, and I divide it by d of x, and it leaves no remainder. The remainder is 0. It means that so I divide p of x by d of x, and I get q of x with no remainder. So my remainder is 0 with no remainder. Then it means that my p of x can be written as d of x times q of x, because my r of x is 0. In this case, we say that this is the function p is divisible by d. And we say that d is a factor of p of x. And this is also a factor of p of x. So I want to look at the factor theory. So the factor theory says that let p of x be a polynomial function. If p of a is equal to 0, then it means that p of x is equal to x minus a times q of x for some polynomial q of x. So what we are saying is, if I have a function p of x, let me clean the board. So if I have a function p of x, and then I have another function d of x, and if my d of x is equal to x minus a. Now, if I divide p of x by x minus a, and I get q of x, in other words, it means that my p of x is equal to x minus a times q of x. It means that x minus a is a factor of my p of x. Now, if x minus a is a factor, it means that when I substitute p of a into the function, I'm supposed to get 0. So if x minus a is a factor, then when I substitute a into the function, I'm supposed to get 0. So that is the factor theory. So this means that this is a factor, this is also a factor. Then when I substitute a, I'm supposed to get 0. Okay, so we want to look at the proof. It says that let p of x be equal to the divisor times the quotient. Then at s equal to a, so at s equal to a, since p of x is equal to x minus a times p of q of x, when s equal to a, I'm going to get p of x equal to a minus a times q of a. And thus a minus a, I know this will give me 0. So it means that my p of a is equal to 0. Suppose now that p of a equal to 0. That is s equal to a is a 0 of p of s. Then we prove that x minus a is a factor of p of x. So we express p of s as p of s is equal to d of x plus q of s. Okay, so first we've been able to prove that p of x minus a is a factor. The next one, I want to prove that since x minus a is a factor, my remainder will be equal to 0. Okay, so I know that when I divide p of s by d of s, it's supposed to be d of s times q of s plus r of x. Okay, now my d of s is s minus a, then q of s plus the r of x. But r of s is a polynomial of degree 0, that is a constant. Since it is assumed that p of a equal to 0, so so first one, we're able to prove that p of a is 0. So I'm going to write s minus a, q minus s plus r of s equal to 0, because I know my p of a equal to 0. Then I know that s equal to, I have a minus a, q of a plus r of a equal to 0. I know that a minus a is 0, so 0 times q of a will give me 0. And I'll be left with r of a, and r of a will also be equal to 0. So this implies that if x minus a is the factor of the function p of x, then it means that my remainder is 0. So this implies that p of x is equal to x minus a into bracket q of s, which means x minus a is a factor. Hence, that is the result. So first, we have to prove that please, I'm going over the proof again. No, now we are told that x minus a is a factor. So we are proving that if x minus a is a factor, then my p of a should give me 0. So if x minus a is a factor, it means that my s is equal to a. So I find f of a, and f of a will give me 0. That is one. Then the next one, we know that p of s can be written as d of s, q of s, plus r of s. So we have to prove that the remainder will be 0. Please excuse me. Please excuse me. Hello. Okay, so as I was saying, we want to prove that the remainder is 0. So we have p of s is equal to d of s, q of s plus the remainder. We know that our d of s is x minus a. So I have x minus a, q of s plus the remainder. Okay. So we also know that our p of a is 0. So if p of a is 0, then I have x minus a, q of s plus this equal to 0. Then I know x is a, so I have a minus a, q of a plus r of a equal to 0. And we know that this will give me 0. So my r of a will also give me 0. So if my r of a is 0, then it means that please excuse me. Let me pick this one. Hello, Mike, your hand is up.
I'm sorry, long time. Oh.
No problem. Okay. It says that in the factor theory, if P of S is equal to X minus A times Q of S, then X minus A and Q of X are both factors of P of X. So example, it says that find the factors of the polynomial function P of X is equal to S to the power 3 minus X squared minus 5X minus 2. Hence, find the other factors. Okay. So to get the first factor, this one we are not given any factor, but first we have to find one factor for ourselves. And to do that, I think it's a bit difficult. So what do you normally you just try. Okay, so we have another formula way of finding it. But before we get to that place, what we do is we use try and error. So you choose one, you substitute one, negative, positive one, you substitute and see if it will work. You choose 2, you choose 3, you choose -1, -2, and so on. So when you do that, you will see that X minus 3, which is the same as S equal to 3, is a factor. Because when you substitute P of 3, you're going to get 27 minus 9 minus 15 minus 3, and this will give you 0. So it means that X minus 3 is a factor. So after you've gotten X minus 3 to be a factor, then you have to use long division to obtain the other factors. So the long division that we used, so you have X to the power 3 minus X squared minus 5X minus 3 divided by X minus 3. And you see that when you use the long division, your quotient will be X squared plus 2X plus 1. So the function will be the product, the divisor times the quotient, and it will leave no remainder since it's a factor. So you're going to get something like this. And thus, when you solve this, this can be written as S plus 1 to the power 2. Please, when you solve this, you see that you're going to get repeated roots, and that is S equal to -1. Okay, so you're going to get x equal to -1 twice. So the function is x minus 3 into x plus 1, then times another x plus 1. Okay. So therefore, the factors of P of x are x plus 1 and x plus 1 squared. Sorry. So the factors are supposed to be x minus 3 and then x plus 1 squared. Yeah.
Madam, please, if we ask to factorize the polynomial, like the one you just did, if you find the first factor and then you're able to use the long division to get the s minus 3 and then the quadratic. The quadratic one, can you use the normal quadratic factorization or you are supposed to use the polynomial long division?
Yeah. You can use a normal quadratic formula to get that.
All right, thank you.
You're welcome. Okay, so we are on what we call extended factor theory. It says that let A1, A2, A3 up to An be m distinct zeros of the polynomial function. So we have A1, A2, A3 up to An. They are all distinct factors. So since they are zeros of the function. So since they are zeros, then we can write our P of x as x minus A1, which is a factor, times x minus A2, x minus A3 up to x minus Am times our Q of s. So here we say that P of x is factorized into m linear factors and another polynomial function or factor Q of x. So example, if I have Q of x is equal to x to the power 3 minus 6x squared plus 11 minus 6. So first, as I said, you have to find one of the factors. So maybe we substitute s equal to 1 into it, and then s equal to 1. Then we've gotten that to be the 0. Okay, so it means that x minus 1 is a factor. Okay, so you use long division to get the other factors. So you're going to get a polynomial function. You use long division, then you're going to get x squared times something. So after solving, it's a polynomial function. So after solving, you get x minus 2 times another function, linear function or polynomial function. And that is x minus 3. So when you solve this and then you get x minus 1, x minus 2, x minus 3, then the polynomial function P of x is factorized into two linear factors, that is x minus 1, x minus 2, and another polynomial function, which is also linear. So that is the extended theory. It says that we can have the linear function times our Q of x, and here our Q of x is also linear. So that is our Q of x. So that is the extended factor theory. Okay, so the next thing we want to look at extended factor theory with multiplicity. So that's why we are saying that if I have a1, a2, a3 up to am to be distinct zeros of the polynomial P of x, then my polynomial function can be written as x minus a1 and then to the power r1, x minus a2 to the power r2 up to x minus am to the power rm times q of x. Here, the r1, r2, r3 up to rm, we call them multiplicity of the zero. Multiplicity of the zero. And we know that our q of x is a polynomial function having no real zero or is a constant. So my q of x can be a constant or a polynomial. Okay. So example is this. So when we take this one, this can be written as x minus 1 to the power 1, x minus 2 to the power 1, x to the minus 3 to the power 1. So here the multiplicity of the factor s minus 1 is 1. Multiplicity of the factor s minus 2 is 1. Multiplicity of the factor s minus 3 is also 1. Then when we go up here, we saw that this is x minus 3, x plus 1 to the power 2. So the multiplicity of this factor is 1. The multiplicity of the factor s plus 1 is 2. So that's what we call the multiplicity. I think there's a hand up. Okay, so please, if there's a hand up, the person can talk. Yeah, Johnny.
Right, madam. Please, with regards to the example that we just did, I'm just pleading that you take us to the word so that Microsoft Word. Then we start, going through step by step. We want to note the step by step.
Please, I didn't hear what you said.
I'm saying that with regards to the example that we just did, and I'm pleading that if we can switch to the whiteboard, then you'll be writing the step for us so that we can note them down. The multiplicity, that aspect.
Thank you very much, Mr. Edu. I think that you didn't allow me to land because I was even showing you example of multiplicity. So I was saying that these are factors and the power here are 1, 1, 1. So this is x minus 1 has multiplicity 1. This has multiplicity 1. This has multiplicity 1. And I was saying that these are also factors. So I have x minus 3, x plus 1. This x minus 3 is a factor. And we know that the power here is 1. So the multiplicity of x minus 3 is 1. X plus 1 is a factor. And the multiplicity is 2. And I think you should understand this. Because looking at what we are supposed to do, we are supposed to end the lectures today. If so, even though you owe me 3 hours, or I owe you 3 hours, so after this, even after today, I have to look for another 3 hours to meet you. But looking at what we have to do, I don't think it's everything that I have to write. I have delayed because I was supposed to, I'm supposed to finish this one and then do something else. So please, I cannot write everything for now. So please just pay attention and follow what I'm doing right now, because I will not be able to write everything on the board. If I continue doing that, then will not be able to finish the course, please. And I am not the only one teaching the course. And not that I'm not the only one. This is what algebra and trig, and you have to get everything that you are supposed to get. So please just pay attention. You can understand it. The notes, when you follow it, you can understand it, please. So I'll not be able to write everything. I'm sorry.
Thank you.
Okay, so another example, we have 2x to the power 4 minus 5s3 plus 3s squared plus 2s squared plus x minus 1. And we want to find the factors. We have to factorize this. So as I said, you have to look for at least one of the factors. So you see that s equal to 1 is a 0.
Madam,
Your hand is up.
yeah, please. Madam, please. With the polynomial function, Madam. I said with this very example, 2x squared, 2x exponent 4, you could see that the 3x squared appears to 3x squared, 3x squared.
So it's a mistake.
Oh, okay.
Okay, so you can see that s equal to 1 is a factor. That it's a 0. That is x minus 1 is a factor. Please know the difference between factors and then zeros. So x minus 1 is a factor, and then s equal to 1 is a 0. Okay, so that means that I can divide this function by x minus 1. So when you divide this function by x minus 1 using long division or any approach that you know, you're going to get the quotient to be 2x to the power 3 minus 2x squared plus 1. This is a cubic function. So you have to find the zeros for this cubic function too. And this one too, when you solve, you will see that x minus 1 is also a function of this cubic function. So you're going to get, you have to divide the 2x squared minus 3x, 2x cubed minus 3x squared plus 1 by x minus 1. When you do that, you're going to get the quotient to be 2x squared minus 1, 2x squared minus x minus 1. Okay, then this is a quadratic function. So you find the factors of the quadratic function, and you're going to see that the factors will be x minus 1 and then 2x plus 1. Okay, so this means that you can see that x minus 1, have x minus 1, x minus 1, x minus 1, and then 2x plus 1. Okay, so the x minus 1, the factor x minus 1 is appearing 3 times. So you can write it as x minus 1 to the power 3 and then 2x plus 1. So this means that the factor x minus 1 has multiplicity 3 and the factor 2x plus 1 has multiplicity 1. Or you can say that the 0 s equal to 1 has multiplicity 3, and the 0, so this one you solve for s, the 0 s equal to negative half has multiplicity 1. I think there is a hand up. Okay, so I have 2 hands up. So let's listen to Daniel.
Please, madam. So after knowing the factor, can you use the synthetic division theory to solve it?
Yeah, yes, please. Yes, please, you can do that.
No.
We want to look at consequences of the extended factor theory. Okay, so Samuel too, I saw your hand up.
Madam, sorry, it is an old hand. Sorry.
Okay. So it says that the n zeros theory, it says that a non-zero polynomial of degree n has at most n distinct zeros. Let the degree of P of S be greater than 0. Then the graph of P of S intersects any line in the plane at most n points. Okay. Okay, so you have an example. It says that the polynomial has S plus 1 as a factor if and only if the alternating sum of its quotients is 0. This proof, we want to skip this proof. You can look at it yourselves, but you can look at it yourselves. Okay. We have f of x is equal to 3x squared plus 5x plus 2. Then the alternative sum of coefficients is x plus 2. So we are talking about the alternative sum. We are looking at this and this, and we can say that 2 this plus this minus 5. I think it also follows from the proof. But as I'm skipping that proof, please, you can look at that proof later. It's repeating. So we have some exercises here. Okay. Then we have what we call replacement theory. Okay, so let me just read the replacement theory, then you'll solve one question. Okay, so we know how to find the factors of a polynomial function. We have looked at the factor theory approach. Then there's another way of finding the factors of a polynomial function, and we call it the replacement approach. The replacement approach. So what we just did is one way of finding the factors. So there's another way called the replacement approach. And the approach says that suppose that a polynomial P of x is in terms of x. If we replace x by another polynomial T of x in P of x, we obtain a polynomial that is in terms of T of x. Assume without loss of generality that T of x is equal to s plus a is linear. If T of x is actually a factor of P of x, then P of T minus A is a polynomial whose 0 is 0. It will then be easier to determine the other factors of the polynomial. This approach of finding the factors of a polynomial is what is referred to as replacement operation. We will illustrate this operation with the following example. Okay, so what we are talking about is if I have a polynomial function P of x, then I will have a factor, maybe T plus A as a factor. Then I'll let my T be equal to x minus A. Then this means that if I make S the subject, I'm going to get my S to be, okay, so that's what I'm talking about. Okay, so that's about the operation, replacement operation. Okay, so the replacement of operation says that if I have P of S, and I have, okay, so I have P of S, then I have a factor, x plus A. So to use the replacement approach, I will let T of x be equal to x minus A. So this means that my x is equal to T, or this T, my T x plus, so my T will be x plus A, which is the factor. So this means that my x will be equal to T of x minus A. So in place of P of x, I'll substitute this. So I have P of T of x minus A. So I'll substitute this into the polynomial function. And when you substitute and then you simplify, you see that you're going to get a polynomial function that has this as a factor. And that's how it works. So let's look at the example. So example, I have P of S is equal to 2s cubed minus s squared minus 8s plus 4. It says that find a polynomial function whose 0 is 0. Hence factorize P of S completely. Okay. So as we just said, we have to find some of the factors. Now, if you try, you see that x equal to 2 is a 0. So this means that x minus 2 is a factor. So you let your t be equal to x minus 2. So you make s the subject, you're going to get s equal to t plus 2. So the polynomial is P of x is equal to this. So in place of x, I will substitute this. So I have P of t plus 2. Wherever I see t, wherever I see s, I will substitute t plus 2. So I have 2 times t plus 2 cubed minus t plus 2 squared minus 8t plus 2 plus 4. Then I'll expand the first one. When I expand, I'm going to get 2 into t cubed plus 6t squared plus 8t, 12t plus 8 minus, when I expand the t plus 2 squared 2, I'm going to get t squared plus 4t plus 4. Then minus the 8 times t plus 2 give me 8t minus 16.
Madam, please, we can't hear you. Hello, madam. We can't hear you.
Hello. Hello, can you hear me now?
Yes, madam.
Yes, please.
Can you hear me now?
Yes, please.
Madam, please, we can hear you, but please, you have to go back a little because we felt it was coming from our end. So we disconnected and connected, not knowing it was coming from. Thank you.
Okay. Okay, so we have P of s is equal to 2s cubed minus s squared minus 8 plus 4. So we know that we have to find one factor. So you will see that when you find one factor, you are going to get x minus 2 to be a factor. So you have x minus 2 to be a factor. Then by the replacement theory, it says that we equate the factor to t. So we let t be equal to x minus 2. So this means that in place of x, so I make s the subject. So my x will be equal to t plus 2. So in place of x in the polynomial function, I'll write t plus 2. So I have p of t plus 2, which will give me 2 times t plus 2 cubed minus t plus 2 squared plus, plus minus, no plus, minus 8 into t plus 2 or plus 4. Like this. The last time was it plus. Okay, plus 4. So we expand. So this is equal to, this is 3. Okay, this is 2. So please, let's expand the c plus 2 to the power 3. What do I get when I expand c plus 2 to the power 3?
I get t
Please
squared.
expand 3 plus 2.
T cube.
You get
T power
t
3.
cube
6t squared. Plus 6t squared.
Is it plus?
Yes. 6t squared.
Please, I'm listening. Oh.
Plus 12t
6t squared.
plus 8 plus 12t
I've written that.
plus 8 bracket close
Plus 12t plus
plus
what?
8 8
Plus 12t plus
8
plus 8. Okay, so that is for the expansion of that. Then minus, what do I get when I expand t? T plus 2 give me
T squared plus 4t plus 4.
a. We want to expand t plus 2 squared.
Madam, you get t squared plus 4t plus 4.
T squared plus 4t plus, okay, then minus 8t minus 16 plus 4. Please, let's simplify. So this is 2t cubed plus 12t squared plus 24t plus 16 plus 16 minus t squared minus 4t minus 4 minus 8t minus 16 plus 4. Please simplify for me. What do you get? So I think I have 2t cubed. Then I have 12t minus t squared. So this will give me plus 11t. Please, are you following?
Yes, please.
Okay, so that is that. Then I have 24t
11t square.
minus, okay,
Please,
11t
would it be
squared.
11t
So I have
square?
20, it's 11t squared. So I have 24t minus 4t minus 8t. What do I get for that? 24t minus 4t minus 8t. That would be what?
12t.
12t
Okay, so
12t
plus 12t plus 12t. So I have 16 minus 4 minus 16 plus 4. What do I get for that?
0.
That is 0. Okay, so the operation, the replacement operation says that when you simplify, when you substitute the t equal to x minus a, or t equal to x plus a, which is t, p of t minus a, you are going to get a polynomial whose 0 is 0. So let's see. We can see that this polynomial function has 0 as its 0, because we can write this as t outside, then 2t squared plus 11t plus 12. So you can see that t equal to 0 is a factor of this. So it says that we're going to get a polynomial function that has 0 as its 0. So that is that. So I can write it as t equal to this. Please find the factors of this quadratic function for me. It's 2t squared plus 11t plus 12. What is that?
Madam,
Teacher 3.
madam, you get negative
Minus
2
get
third. Negative
minus
2
2,
third.
2.
No, find the factors. Factors.
2s plus
Factors,
3.
not the zeros. Factors.
Madam, 2s plus 3 and s plus 4.
Okay. Do we have x there? C or x?
Madam,
Is it x? Is it x?
t 2t
Do we
plus
have x there? We have
madam, the
2t plus
factors
3
are
2t
plus 3.
and
2t
t
plus
plus
3.
yeah and t plus 4.
Yes.
T plus 4. So we found the factors in terms of t. Now we know that t is x minus 2. So in place of t, I will write x minus 2. So the function will now be, I know that t is x minus 2. So my p of x will now be, the first term is t, and we know that t is x minus 2, so I have x minus 2. And you said the second term is 2t, so I have 2 times x minus 2 plus 3. And the last term is t plus 4, which is x minus 2 plus 4. Plus 4. So I will expand, this is x minus 2. When I expand this one, I'm going to get 2x minus 4 plus 3. So which will give me 2x. What will I get? This is 2x minus 4 plus 3. So that would be 2x what? Please expand this one. Please
It will be
expand this
2x
for me.
minus
2x
1.
minus 1.
Minus 1.
Two x minus 1. So please expand this one too for me.
S plus 2.
X plus 2. And this is the final answer we are supposed to get. So this is how the replacement operation works. So we are done with solving the polynomials. Is it okay?
Yes, madam.
Okay. Nanayaw.
Madam, please, for this method, under what circumstance would you be asked to use? Like in exams situation, would you be restricted that use the replacement method, or I don't know how it will be. So if you can help us with it.
No. you have to know. At least you should know some of. That's why I'm
Madam, we don't want any
nice
restriction.
and so.
We just
Not
want to
at all,
be.
not at all. I'm just asking when to don't restrict us,
Okay, so
please.
No, please don't restrict us.
but simple. Okay, so we are looking at factorization of polynomial x to the power n to the power n. X is just n s the power n minus a. So when you use the long,
Your line is breaking.
this, you're going to get this. Is it okay now?
Yes, please.
It's okay.
Okay, so I'm saying that when you use the long division, this function has this s minus a as a factor. And when you use the long division, you're going to get the polynomial to be this. Okay. So example, if I have x, p of x is equal to x to the power 4 minus 16. This can be written as p of x equal to x to the power 4 minus 2 to the power 4. And this means that x minus 2 is a factor from that theory. So x minus 2 is a factor. Then from this here, it means that what we have here, it means that if I write it, I can write it as x minus 2 into brackets x to the power 4 minus 1 plus 2. So you can see that you can write it as x to the power n minus 1, then a. Please excuse me. Please excuse me, let me put this one. Hello. Okay, sorry. Okay, so as I was saying, then I can write it as x minus a. So for the example, our a is 2. So I write it as x minus 2. Then x to the power was 4. So I have 4 minus 1. Then a x to the power, then I have 4 minus 2, a to the power 2, x 4 minus 3, and so on. Okay, so that's what we have. So we're going to, we've seen that x minus 2 is a factor. So I have x minus 2 into x to the power 4 minus 1 plus 2, x 4 minus 2 plus 2 squared s4 minus 3 plus 2 to the power 3. So this is supposed to be 2 to the power 3. Then x 4 to the power 4 minus 4. And we know 4 minus 4 is 0. So s to the power 0 is 1. So I have 1 and then 3. So when I simplify, I have x minus 2 into s to the power 4 minus 1 is 3, plus 2, s to the power 4 minus 2 is 2, plus 2 squared is 4, and then s to the power 4 minus 3 is x, then plus 2 s to the power 4 minus 1 is x, 2 to the power 3, which is 8. So that's what I have. Then I can find the other factors using any method. Okay. So when you use the factor theory, you see that s plus 2 is a factor. And then when you use the long division, you're going to get s plus 2, then x squared plus 4. X squared plus 4, you enter because when you find the discriminant, you see that it will be less than 0. So you enter. So the function can be written as x minus 2, s plus 2, then x squared plus 4. So you're going to get x squared is equal to minus 4, and that will be imaginary roots. So you enter. Then we have another one we call rational zero. Please, we'll look at the theory, but the proof you can look at it later. It says that if f of s is equal to this polynomial function, where a sub I is in z. Now, if p of q is a rational number, in lowest term is a 0 of f of s, then p is a factor of a naught, and then q is a factor of a sub n. So the rational zero says that when you have a polynomial function like this, you take your constant a naught, then you take the leading coefficients. So this is supposed to be a sub n, not a sub n minus 1. Please, I'll make the correction. Okay. Now you find the factors of your a sub n, you find the factors of a naught, and it says that in lowest term, so you divide the factors of the constants a naught by the factors of q naught, that is a naught, in lowest term. Then you realize that you substitute them into this, and you see that some of them are factors of the polynomial function, or the ratio this is a factor. They are factors of the polynomial function, and we call this theory the rational zero theory. So the proof is here. I will skip this. You can take your time. So it says that the least. So the least means that the greatest common divisor is 1. So it says that is p is a factor of the right hand side equal to p is a factor of the right hand side, but p comma q is equal to 1. So the common greatest common divisor is 1. Okay, so please, that is that. Okay, example, we say that we should factorize this and this. So Foster, your hand is up.
Madam, please, can you clarify the last statement that p comma q is equal to 1 and p comma q to the power of n also is equal to 1?
How do I clarify that? I don't understand what you mean by I should clarify it.
Like how p comma q equal to 1 and p comma q
Foster,
n.
Foster,
Madam,
Foster, please, what you're trying to tell me is you don't read the notes. That's what you want to tell me. Because when we were treating real numbers and the properties of real numbers and others, the real number system, I think I mentioned that. So you are trying to tell me that you don't read the notes, and I don't think I have to go back, because I taught you p comma q is equal to 0. It's in the notes. And we even use that in proving one of the theorems here, that square root of 2 is not rational. It's irrational. And we did that. Okay. So we have greatest common divisor. Okay. So you are just telling me that you don't read the notes, please. So please take your time and read the notes. Because I'm not even, yes.
Yeah, please, would there be a case that we are going to prove the theorem in the examination?
I've not thought about that, but you can read it to understand, please.
Okay, thank you.
So here I use that as that thing here, that A comma B is equal to 1. And I mentioned it, I explained it. Even in the notes, I mentioned it in the greatest common divisor. It's here. So first, what you are trying to tell me is you don't read the notes. Because I'm not supposed to teach you that. If you see P comma A equal to 0, you should understand what it means. We did it this semester. So you are not reading the notes. Please read the notes. Thank you.
You're welcome, madam.
Okay. So on the question, we have 12s to the power 4 plus 4s cubed minus 21s squared minus 16x minus 3. And we want to use the rational zero theory. So it says that my a sub n is 12, and then a sub naught is 3. So I find the factors of 12, which is my q. So the factors of 12, I have 1, 2, 3, 4, 6, and 12. Then I find the factors of a naught, which is 1 and 3. And it says that I should find p over q. And in the theory, it says that, please, who is there? Oh, I'm supposed to even solve this one first. Okay, but it's the same thing, whether I solve that one. It says that it says that if P of Q is a rational number and in the lowest term, so it means that my P comma Q should be equal to 0. And that is the greatest common divisor. So if both of them should be relatively prime and their common factor should be 0. Okay, so if I choose this, I have 12 and then 10. So my Q's will be 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 6, and 12. Then when I pick the 10, I have 1, 2, 5, and then 10. So I will divide the P by Q. So you divide the P's by Q, and then in the common, like lowest term, you're going to get the set 1 over 2, 2 over 3, and then 5 over 2. So please, you can take these terms here and divide them by this. Some of them will be repeated, but this is the set that you're going to get. So you substitute. So it means that my functions will be, I have the first term to be 1 over 2. So I substitute 1 over 2 into the function. Okay. You simplify and you are going to get 0. So if you get 0, it means that x is equal to 1 over 2 is a 0. This means that 2x minus 1 is a factor. So you come to the next one, 2 on 3, and you substitute that 1, 2 into the function. So you substitute 2 on 3 into the function. Then when you simplify, that will also give you 0. So this means that my x is equal to 2 on 3 is a 0, and 3x minus 2 is a factor. So that's the second factor. Then the other one is 5 on 2. So you have x equal to 5 on 2. You substitute that into the function. Okay. And you're going to, when you simplify, that will also give you 0. So this means that x is equal to 5 on 2 is a 0. So 2x minus 5 is also a factor. So it means that that function, you're going to get 2x minus 1, 3x minus 2, and then 2x minus 5. So let's look at this example. Here, my Q, I have to find the factors of 12. So I have 1, 2, 3, 4, 6, and 12. Then I take my 3, I find the factors of 12, which is 1 and then 3. So I divide my P by Q. Okay. So it says that P comma Q should be in a bracket should be greater than equal to 0, equal to 1. Okay. So when I do that, I'm going to get P over Q to be 3 on 2. Okay. So when I substitute that 3 on 2 into the function, I'm supposed to get 0. So the function will now be 2x minus 1. Then I use long division to get the other factor, which is this. And I should be able to find the other factors. So thus, I can still use the rational zero approach to find the factors. So this is 6, this is 1. Then I can find the factors of 6 and then the factors of 1. Okay. Then you divide. Okay. So by inspection, you are saying that by inspection, s equal to minus 1 is a factor. So when you look at this, by inspection, s equal to minus 1 is a factor. So you use long division, and you're going to get x plus 1, and then 6s squared plus 5s plus 1. This is a quadratic function, so you will see if it is divisible. So you find the factors, and the factors will be 2s plus 1, and then 3x plus 1. You can still use the long division, the rational zero. You find the factors for this, then factors for this, then you solve. Okay. So you're going to get that. So that's how to find the factors of the polynomial function using the rational zero. So this rational zero approach is a way of finding the factors. So you can decide to add, but since you're going to teach, you have to know this, that you have rational zero approach. And this rational zero approach, what you have to do is you find the factors of the leading coefficient, you find the factors of the constants, then you divide the factors of the constant by the factors of the leading coefficient one by one, and then you make sure that they are in their lowest form. Okay. Then you substitute them into the function. You see that they will be factors or zeros of the polynomial function. So that's all about the rational zero. And then we also have the replacement operation. That's also used to find the factors. That is, you get one of the factors, maybe s is equal to a, that is x minus a is a factor. So you let t be equal to x minus a. Then you substitute, in place of x in the function, you substitute t minus a or t plus a. Then you will see that when you expand and simplify, you will get a polynomial function whose zero is 0. Okay, so after that, you find the factors of the other functions within the brackets with t. Then you, after expansion, everything, after getting the linear function, you substitute, in place of t, you write x minus a, then you expand. That would be the solution. And then we've also learned about the factor theory. So we know the factor theory. Okay, so want to continue. Okay, so when we treated the polynomial function, we saw that when we treated the quadratic function, we saw that when we are given, okay, it's even here. Okay, so for a quadratic function, it says that if x1 and x2 are roots of the quadratic function ax squared plus bx plus c equal to 0, then we can write the function as a into bracket x squared minus sum of roots x plus product of roots all equal to 0. Okay, so when we expand this, we are going to get A out x minus x1 times x minus x2. So that is for quadratic. Then we saw that x1 plus x2 is equal to minus b over a, and then x1 times x2 is equal to c over a. So if the function, so that is for quadratic function. Now, if the function is cubic, then it means that we are supposed to get 3 roots. So this is a cubic function. We are supposed to get 3 roots. So when I simplify, I can get it as a outside s cubed plus b over a s squared plus c over a s plus d over a in a bracket equal to 0. Since it's a cubic function, I'm supposed to get 3 roots, r1, r2, r3. So if I have 3 roots like this, 3 zeros, then it means that the function can be written as x minus r1, this is a factor, s minus r2, and then x minus r3. So when I expand, this equal to 0 because they are roots or they are factors, it should give me 0. When I expand this, the whole of this, I'm supposed to get s to the power 3 minus the sum of all the roots, s squared, plus sum of x1, x2, product of x1, x2 plus, sorry, it's r1, r2 plus r1, r3 plus r2, r3 times x. So you see that I have r1, r2, r1, r3, r2, r3 times x minus then the summation of all the 3. So if it is to the power 3, this is how we, and then we have the factors r1, r2, r3. This is how the solution will look like. So when I compare this, the two, when I compare this to what I have here, so it means that my b over a, it's the sum. Okay, so it's equal to r1 plus r2 plus r3 is equal to minus b over a. Okay, so it says that my r1, r2, r3 is equal to minus b over a. And then the summation of the products of two of the function, that is equal to c over a. I think you can see it here. Okay, so that is here. And then the product of all the 3 will be d over a. And I think here is negative. So it's negative d over a. So the product of all the 3 will give me minus d over a. Therefore, in terms of its roots, r1, r2, r3, the cubic equation is a outside. Then I have s to the power 3 minus the sum of the roots x squared plus. So this is r1, r2 plus r1, r3 plus r2, r3, all in a bracket x minus the product of the roots. That is for cubic function. Now I want to get it for a general form for polynomial function. So if I have a polynomial of degree n, I know that my root will be r1, r2, r3, up to rn. In that case, comparing it with the quadratic and then the cubic, you know that I will have a sub n outside. Then I have s to the power n. So you can see that when it's quadratic, I have s to the power 3. When it's cubic, I have s to the power 3. When it's quadratic, I have s to the power 2. Then I have the sum of all the roots. So I have a sub n outside, s to the power n minus the sum from I equal to 1 to n, x in minus 1. Then plus, so I will have, please, I think there should be ri here. So sum of all the ri's. So there should be I. So there should be ri here. Then when you come here, this is summing from I less than j. So I have ri, r sub I, and then r sub j. So this one, I will take 1. So when it's the first one, I will take 1, 2. Then I have 1, 3, 1, 4, 1, 5, and so on. Then I have 2, 3, 2, 4, 2. So that is for this one. So I'm summing all of them. Then it means that that is x to the power n minus 2. So the next one, it will be x to the power n minus 3. And I'm going to have product of 3 of them. So I have R1, R2, R3 plus R1, R2, R1, R2, maybe R4, like that. Up to the last one will be minus 1 to the power n. Then product, this one, when you see pi, I to the power 1 to the power I sub I equal to 1 to n. When you see pi like this, it means that I am multiplying all the ri's. So this one I can write it as pi from I equal to 1 to my n is 3 ri's. So it means that I have to multiply R1 by R2 by R3. So when you see pi like this is what it means. Okay, so this is the general form of finding the equation for polynomial function given the factors. Okay, so we are expanding. Thus the zeros are related to the quotient as this. So Ri is like this. Ri, Rj, the sum is like this. Please, you can take your time to look at it. But I mean, say so you just, these are some questions. You can go through them, but you can end on the cubic function. This you can just read maybe later, but you can end here. So you can tell your other friends to learn up to this one. But it's better you also know how to write the summation signs, or you are able to understand this and this. So if I have K1, K2, K3, K4, K5 cases that I want to multiply, I can write it as pi equal to 1 to 6 and then Ki's. So this one, any mathematician will know that you want to multiply the case if this is K. And then this one, every mathematician knows that you are multiplying the KRs from 1 up to n. So that is what this one means. So you have some questions here, you can go through them. Hello, please, I want to continue. What time are you supposed to go for the break? Hey, number one line there.
I think, Madam, we should continue.
Madam,
But you didn't mind me. I asked if you're okay. You didn't mind me.
There's no break.
You were praying and
then let's continue. I hear. But I think that, please, you have to read. You have to read. You have to get more time to study this,
Madam,
please.
it seems there are some part of these topics. You don't even see the real implication of the topic in our normal life. So, Madam, if you could limit it to the.
Are you sure? Please, no, you will see them. Please, mathematics. At the beginning like this, you will not see the application. But as you go higher, you will see the application. So please, you see that we have applications, but just that you need the theories before you apply them. And we do mathematics, we apply mathematics in all fields, from engineering to medicine, everything, we apply them. So I think that for right now, you may not see it right now, but a person reading engineering or in medicine or something will take some aspects of what we are learning here and I apply it there. Somebody in economics and other finances and other fields, they will take part of the economics. But you are a teacher, you are going to teach. So you have to understand everything, all the concepts, so that you teach the students, so that when they go to their various fields, they will be able to apply. So you need understanding right now to teach. Then when they go to their fields, they will apply. So an engineer who is constructing a bridge or something will need eigenvalue, but you have to understand eigenvalue. How do you get eigenvalue? So you should know how to know that to be able to find the eigenvalue, you have to find the a characteristic polynomial. How do you find characteristic polynomial? How do we solve? And to get that characteristic polynomial, you have to get matrix. And how do you get matrix? If somebody is building a house, how does the person get the squares and other? They all need mathematics. So some of the pillars are supposed to be round, some of them are supposed to be square. So all those things, they need math. So you see that when you go to the construction field and then they want to erect a pillar, the ground one, they will have the square thing over there. So all those things, they are all mathematics, but just that you will not need everything at one particular point. We need them in different fields. So maybe there is an outbreak of a disease and we want to find out if this disease will be in the system for a long time. That is, if it's going to be endemic or die out soon, then you have to calculate what we call the basic reproduction number. And to calculate the basic reproduction number, you need mathematics. And if the basic reproduction number is greater than 0, is greater than 1, it means that the disease will continue to persist in the community. So if for malaria, those who calculated, they saw that it's greater than 1. Some are saying it's around 10 or something like that. So it means that it's going to persist in the system. So what do we do? So we have to look at the interventions. When there was COVID, I don't know if you listen to the news, you see that some people will come to the state TV stations and tell us that the basic reduction number is this. So what are some of the things that we have to do? Then they will advise us that we have to avoid contact, like moving going out. We'll have to do lockdown. So they will use mathematics to calculate it and then inform us. So when you go to the outside world, when they are solving in the medical field, in the research centers, they would need a mathematician who is an epidemiologist, but mathematician, then they will solve. So this person will solve, this person will interpret, and then you continue. But even before you be able to solve the basic reduction number, you need to understand all these things. Because we just realized that Foster asked, what is P, R? But P, R equal to 0. We have done it somewhere. So you have to combine all the things that you know from somewhere. So please, the application is there. Don't say that you don't see the application. We have the applications, but you have to go higher to be able to see the applications. So for right now, we learning what we call the this pure mathematics. Then when you go higher, you see the applied mathematics. So please try and then endure and learn, and everything will be fine. And you are a teacher, so you don't know the fate or the future of your students. You don't know if your student is going to be a medical doctor. You don't know if some of your students are going to be engineers. You don't know how many of them are going to be the scientists, the world scientists. So you, as a teacher, you have to learn, understand, and teach them so that the engineers will take their parts and apply, so that the economics those who will do economics will also take their parts and then also apply it in their field. So that's the reason why the art students are learning elective maths. Business students are learning elective maths. Science students are learning elective maths, and then other people are also learning elective maths because they will apply them in their fields when they are calculating inflation at the Bank of Ghana. I think I went there last time, and I have a student here that I taught. He's working there, and before even the government statistician will come out with his value for inflation rates, the Bank of Ghana will do DS using simulations. And my student was the head, he was doing that. So you see, he also did some, he is applying part of what you are doing, even though he's not applying everything, he is applying parts, and you will need some basic understanding. So please, you can say that you don't see them in real life. We see them. You think that the inflation rates that they give to us every day is coming from where? It's coming from mathematics. So please, let's try.
Setting the questions. So the course is loaded. You have to help us in setting the questions.
We'll think about it. Okay, so let's continue. We are now on rational functions. We know what a rational number is. Examination what?
Fever is heating up.
Okay, so let's continue. We want to look at rational functions. So we know what a rational number is, any number that can be expressed as a fraction. Okay, so when you talk about rational functions, then a function that can be expressed as P of x over Q of x is called a rational function. And then when you have a rational function, you have to find what we call domain. So domain of f of x is given by s such that s is in R and P of x should not be equal to 0. So this should not be equal to 0. The unfortunate thing is most of you did not do elective maths. And because if I'm to teach my regular students, the domain range, they know already. So I will not waste my time there. When I mention rational, they should know what a rational function is. But you are making my work very difficult. Every day after teaching 4 hours, then who say you've taken a lot of things from me. My kankasa. Because most of you didn't do it, so I have to talk, say everything, explain everything. But if you were to be elective math students, so in the above definition, you've done what?
You will buy energy drink for you.
I hear. In the above definition, it can be observed that if P of s is equal to n, then there are at most endpoints where P of s is not defined. Consider the function y is equal to P of s over Q of s. For Q of s is not equal to 0, the range of the function at the value of y corresponding to the domain of f. The range is obtained by finding an expression for s from the given function. Such an expression is in terms of y of the form s equal to h of y. The range is therefore the value of y for which x is defined. The value of y for which s is undefined is what is referred to as the horizontal asymptote to the curve of the function. The curve can also have an oblique asymptote. In this case, you will observe the value of y for which x is undefined is also in terms of s. The vertical asymptote is the value of s for which the function is undefined. The graph of a function only approaches the asymptote but does not cross or touch it. However, there could be a few exceptions. Okay, so when we talk about the domain, to find the domain of a function, that's what we do. We equate our denominator to 0 and we solve for x. When we solve for x, the value that we get for x are not in the domain. So example, I'm tired, Papa. Make kasasa, BS, make kawasa. I'm really tired. Of course, especially more relative matters. It's very difficult.
Oh, madam.
Very.
Boy.
Now
Oh.
we still have 2 hours.
Madam, the one I relative mass no so check.
Yeah, moving so madam, you actually, and only problem you
Madam,
Yeah, divert.
Because when I make, I'm not supposed to give examples of domain. You should even know, or at least my boss of our Okay, so if I have f of x,
Madam Bato, what brand Yama break bear one na?
okay, so I have 2x minus 1 over x squared minus 1. So to find the domain of this function, we are talking about the value of s that will make this function defined. Every value of s that makes this function defined is in the domain. But those that will make this function undefined are not in the domain. So to find the domain, I will equate this to 0. Then I'll solve for my x. So here my x, what will be the value of x?
1.
Plus or minus 1.
Plus or minus 1. Okay. So it means that when I substitute plus or minus 1 into this function, the function will be undefined. So when I substitute positive 1, I'm going to get 1 squared minus 1, which will be 0. And this divided by 0 is undefined. When I substitute minus 1, I have minus 1 squared, which is 1 minus 1. It will be undefined. So the domain is the value of it that will make this function defined. So domain is x such that x is in R, but x should not be equal to plus or minus 1. So my domain is every real value except plus or minus 1. So you can write except here. Okay, so when you bring the except, you can write except s equal to plus or minus 1. So when you substitute any real value into this function, it will be defined. But when you substitute plus or minus 1, it will not be defined. So the domain is s such that s is equal to R, but s should not be equal to plus or minus 1, or except s equal to plus or minus 1. So to find the domain, you equate the denominator to 0, then you solve. The s value that you get will not be in the domain, but any real value will be in the domain. And then to find the range, you have to find the inverse of the function. So you find the inverse, and then after finding the inverse, the domain of the inverse, you use the same approach, and that will be the range of the function. Okay, so we are continuing. So we are saying that when you have a rational function and what you want to sketch, after finding the domain and the range, we have what we call asymptotes. And the asymptotes, we have what we call vertical asymptotes and then the horizontal asymptotes.
Yeah, madam, my issue is the range. This is the range. You have to make the s the subject, and then you find the value of y, which make the function.
Yeah.
But
Yeah.
sometimes what's happened if you are unable to completely make the x the subject, where you see you still have the s mixed with the y. I don't know how to put it. I saw a question like that. I was not able to do it, but unfortunately, like S could not be made the subject completely.
So you make assumptions.
Okay.
Okay, so it says that the line S equal to A is a vertical asymptote to the graph of f of s when f of s approaches 0 or f of s approaches negative. F of s approaches infinity or f of s approaches negative infinity as s approaches A, either from the right or from the left. And the horizontal asymptote is the line y equal to b, where f of s equal to b as s approaches plus or minus infinity. I'm tired. Okay, so let's look at simple.
Madam, the way you are saying you are tired, let's pray for some 30
The
minutes.
break is very necessary.
When I break right now, I have a lot of things to do to have to attend to my children, and so let's finish and so that I can get time to take care of them.
Okay.
Okay, so let's look at this function. We want to find the vertical and then the horizontal asymptotes. So to graph a function, you find the range, the domain, then you find what we call vertical asymptotes and then horizontal asymptotes. So the vertical asymptotes written, I write VA. They are the values of x that makes the function undefined. So the values that we said they are not in the domain, we call them the vertical asymptotes. So to get the vertical asymptotes, I write s squared minus 1 equal to 0. I solve and I get s equal to plus or minus 1. I call this one the vertical asymptotes. S equal to positive 1 and s equal to minus 1 are the vertical asymptotes. Now we have what we call horizontal asymptotes. The horizontal asymptotes are the limiting values of this function as s approaches infinity. Okay, but there's a simple way of finding the horizontal asymptotes. The simple way is I have to look at the leading coefficient for the numerator and the leading coefficient for the denominator. Then I have to look at the degree of the numerator and then the degree of the denominator. So please, to solve for the horizontal asymptote, you look at the degree of P of x. So I'm writing this as P of x over Q of x. So you look at the degree of P of x and then degree of Q of x. Ishra? Now, if the degree of P of x is less than the degree of Q of x, please take note. So to find the horizontal asymptote, you look at the degree of the P of s and the degree of the Q of s. If the degree of P of s is less than the degree of Q of s, then your horizontal asymptote will be the line y is equal to 0. This is a simple way of finding the horizontal asymptotes. The second one is you look at the degree of the P of x and then the degree of Q of s. If the degree of P of s is equal to the degree of Q of s, then my horizontal asymptote will be the line. So I'll look for the leading coefficient of U of x. So let's assume my P of s is a sub n, the power n divided by b to the power n something. So if they have the same degree, I look for the leading coefficient. The leading coefficient of P of s is A, leading coefficient of Q of s is B. So my horizontal asymptote will be the line A over B. Now the third one. If the degree of P of s is greater than the degree of Q of s, then it means that there is no horizontal asymptotes. Please pay attention to these three rules for horizontal asymptotes. For vertical asymptotes, there we know that we have to solve for x for the denominator, and the x values that we get, they are the horizontal asymptotes. And then they are the vertical asymptotes. And the horizontal asymptotes, you have to look at the degree of my numerator and the denominator. If the degree of the numerator is less than the degree of the denominator, then my horizontal asymptote is the line y equals to 0. If the degree of the numerator is equal to the degree of the denominator, then my horizontal asymptote is the line y equals to a over b. If the degree of the numerator is greater than the degree of the denominator, then it means that there is no horizontal asymptotes. Is that okay?
Yes, please. Yes.
Yes, please, madam.
Okay, so let's continue. So with what I just told you, looking at f of s is equal to 2s plus 1 over s plus 1, what will be my vertical asymptotes?
Adam, negative one. That's negative one.
Okay, so my vertical asymptote will be the line s equal to negative 1. Okay, then what will be my horizontal asymptotes?
A over B.
So it will be
Y equals 2.
It will be 2.
Y equals 2.
Y equals 2.
Okay, so your vertical asymptote is, thank you. So vertical asymptote is the line s equal to minus 1. So you take your xy plane, and then the line s equal to minus 1 is your vertical asymptote. And the horizontal asymptote is the line y is equal to 2. So you take that. Okay. So you just draw the xy plane. Thank you very much. Read the Matthias here.
In Temha.
So you have the SY plane. You have 1, 2, 3, -1, -2, -3. Then you have maybe 2, 4. So you have 2, 4. Or negative 1, 2, 3. Okay, so we said the line s equal to -1 is the vertical asymptote. So that's how we do it. So you form some broken lines. So the line s equal to -1 is your vertical asymptote. And the horizontal asymptote is the line y equal to +2. So the line y is equal to +2 is your horizontal asymptote. So that is it. Then to sketch the graph, you have to look at the behavior of the graph as you approach one, either from the left or from the right. So you are approaching -1. So we just saw that the vertical asymptote is the line s equal to -1. So that's what I always do. I can draw a table. You can decide to look at it and then give an answer. But the table that I'm coming to draw, you don't need it when you are solving. But you can do a rough work somewhere, and then you will see the behavior. So now we want to look at what happens as we approach the graph from the left. So I'll have my vertical asymptotes, which is s equal to -1. And then I have my function f of x. Okay. Now I want to approach the -1 from the left. So the left means that I'm going to look at values less than -1. So negative values. So you choose negative values, and then you look at what happens to my f of x is 2x plus 1 over x plus 1. Is it 2x plus 1? Okay. 2x plus 1 and that. So that's my f of x. So I want to choose values less than -1. So please choose values for me.
-3.
Okay, so I'll choose -3. So let's substitute -3 into the function and see what you're going to get. What do you get? So the top one will be negative 6 plus 1, which is negative 5 over negative 2, right? So what's the value of negative 5 over negative 2? Is it negative 5 over negative? Okay, negative 5 over negative.
Okay, negative 5 over negative 5.
So negative 5 over negative 2 is 1 point something. 5 over 3, 5 over 2. 5 over 3,
5 over 2. 2.5.
2.5. Then choose another one. This one we are moving. We are moving close to negative 1 from the left. So since you have chosen negative,
So negative
you should choose value greater than
Negative 2.
53. Okay, who is giving us feedback?
Please, can we raise our hands?
Please mute the mic for me. So negative 2, you are saying negative 2. So what do I get when I substitute negative 2? So that's negative 4 plus 1, which is negative 3 over negative 1. So what do I get?
Now you get 3.
3.
Okay, so choose another one greater than negative 1. Greater than negative 2. By getting closer to negative 2. Who is that? Please choose another one for me. You can just say it, then after that you mute.
You can just say it, then after that you negative.
Please, I didn't hear. Value close to negative 1. Negative 1.5. Okay, so what do I get when I choose negative 1.5? So I have 3 plus 1. So negative 3 plus 1 is 2 divided by 0.5. What do I get?
Madam,
What will I get when
you get 4?
You get 4. Okay, so let's choose another one. Maybe 1.01. It's also close to negative 1.01. So use the calculator and let's see what you're going to get. Or negative 1.0001.
Madam.
Please,
when you substitute in negative 1.01, I had 102.
102. Then substitute negative 1.0001. This one, so we are getting very close to 0.1, but we are not at 0. We are getting very close to negative 1, but we are not at negative 1. There's negative 1.0001. What do I get?
Madam. 10002.
Okay. Can you see a pattern? If I make it 1.00000001, you see that this will be a very huge number. Can you see it? So as you approach negative 1 from the left, you see that as you approach negative 1 from the left, your f of x value is also approaching positive infinity. It's becoming very big. Can you say it?
Yes. Yes, madam.
Okay. So we will put this one down. Then let's go back and then approach negative 1 from the right. So we approach it from the right, and please choose values for me.
1.
Now let's start from 3.
Let's approach it from 3, positive 3. Okay. What will be the value of f of x?
Yes.
7 on 4.
7 on 4 is
1.75.
1.75. Okay, so let's choose another one.
2. Positive
2. So what do I get?
1.66667.
Let's choose another one.
Madam 4.
No, we are approaching negative 1. So you have chosen 3, 2, so please calm down.
When we choose 1, we will get 1.5.
1.5. Okay, choose
Yes,
something
please.
else.
0.5.
3.
Let's choose 0. What do I get when I choose 0?
You get 1.
Madam, you get 1.
1.
Let's choose something else. Negative 0.5.
You get 0.
Negative 0.5 is 0. Let's choose negative 0.9.
Negative 8.
Negative 8. Let's choose negative 0.999. 9, 4 zeros. This is close to negative 1. What do I
Madam,
get?
please, how many 9s?
4.
Negative 9998.
9998. Okay, let's choose negative 0.9999999. So what will I get? You see that I will get negative a big number, right?
Yes, please.
So this means that as I approach negative 1 from the right, my f of x is also approaching negative infinity. It's approaching infinity. So when I sketch the graph, so this is rough work. You do it somewhere. What I need to see in the exams is what this, as s approaches 0 from the right, my f of x is approaching positive, negative infinity. As s approaches negative 1 from the left, this is approaching positive infinity. This is what I want to see, not the table. Okay. So you draw the graph. The graph is like this. You have y, you have x, you have y, you have the horizontal asymptotes. Y equal to 2, so this is 2. The vertical asymptotes s equal to negative 1. It's like this. Then we saw that approaching s from the left, x is approaching positive infinity. So I will draw it like this and go up. Okay. Then approaching it from the left, you saw that this is also approaching negative infinity. So I'll draw it like this. Then I'll go down like this. So this is how the graph will look like. So from this, you see that it's moving close to the graph and then getting to infinity. Yeah, it's moving close to the graph. This it should move close to the graph. In the note, it says that it comes close to the asymptote, but it doesn't cross it unless some exceptional cases. Okay, so that's how the graph will look like. So, but with this, you find the vertical asymptote, horizontal asymptote, you have to find your intercept, your x-intercept. So you have the function is f of s is equal to 2s plus 1 over x plus 1. So you find the x-intercept. So at the x-intercept, y equal to 0. So my x-intercept will be s equal to -1 on 2. So you plot it 0, -1 on 2. I think that's what we get here. And then you find your y-intercept at the y-intercept is equal to 0. Okay, so my x-intercept is -half 0. Then you find your y-intercept at the y-intercept is equal to 0. So that one you're going to get 1. So that would be 0, 1. So you plot that one too. So I think that one will be here, 0, 1. And then you plot some points. Maybe when s equal to 3, you have something here. When s equal to 5, then you plot some few points, and then some few points here. So that will give you your graph. Okay. So when you sketch, you're going to get something like this. That's what we did. Okay. So find the vertical asymptote. I've mentioned that you equate x plus 2 to 0. So that will be your -2. That is your vertical asymptote. And the horizontal asymptote, I'll give you the 3 rules. So you know how to find the horizontal asymptote. So if I have 1 over x minus 2, if I want to find the horizontal asymptote, I know the degree of the numerator is 0, degree of this is 1. So my horizontal asymptote will be the line y equal to 0. That is 1. And then this one, I have 3x over 4. The degree of the numerator is 1. Degree of the denominator is 1. So my horizontal asymptote will be 3 over 4. And then here we have the degree of the numerator to be 3 and the degree of the denominator to be 2. So it means that there will be no horizontal asymptotes. Okay. But we can find the vertical asymptote. The vertical asymptote, you have to solve the denominator. So we're going to get plus or minus 2. So that will be my vertical asymptotes. Okay. And it says that the domain, so you find the domain and then you find the range. So the range, you have y this, you just make x the subject. So that's what you mentioned, that you solve and you still have x inside. Therefore, s is giving us this. Okay. So you have 4y that's greater than 0. Okay. So last time you saw that when you have something like this, you have to multiply it through by the square of this function. Multiplying through by y minus x squared and simplifying gives the inequality y into y minus 4 that's greater than 0, which satisfy the value. So we find the solution. Here we have y. When we solve, we're going to get y less than or equal to 0 union y less than or equal to x. So I taught you how to solve inequalities. However, if y equals to x is not defined. Therefore, the range of the function is y such that y is less or equal to 0 and then y less than x. So please, you solve that. Okay. So the line y equals to x is thus an oblique. Okay. So please, when you find the horizontal, after finding the horizontal asymptotes, and you realize that the degree of the numerator is greater than the degree of the denominator by 1. So looking at this, you can see that the degree of the numerator is greater than the degree of the denominator by 1. When it happens like that, it means that there is no horizontal asymptotes. And if it's like this, it means that we can find what we call the oblique or slant asymptotes. So please, if the degree of the numerator is greater than the degree of the denominator by 1, then there's no horizontal asymptote, but we can find what we call oblique or slant asymptotes. And to do that, we have to use long division to solve this. So we use long division to solve. So it says that so when you use long division, you will see that, okay, so long division. Okay, so the function is f of s is equal to s to the power 3 over what is the function? Over s squared minus 4. Is it negative? S squared over s is s4 minus 4. So I have s squared minus 4 like this. So I have to use long division to solve this. So long division, I have s cubed and then s squared minus 4. So when I divide this, I'm going to get x. I multiply, I have negative. This time, this will give me minus, sorry, it's give me s squared, s cubed. This time, this will give me minus 4x. So I subtract, this will give me 0, and this will give me 4x. So my remainder is 4x. So I can write the function p of s is equal to, the divisor is s squared minus 4. The quotient is x, then plus my remainder. Or I can write it as x plus 4x over s squared minus 4. Okay, so this, I call this one the oblique asymptote. So oblique asymptote is the quotient. The quotient you get is your oblique asymptote. So the line y is equal to x is what I call the oblique asymptote. Okay, so to sketch this graph, I know that I'm going to get my vertical asymptotes to be plus or minus 1. So plus or minus 2. So I will do this. I have 2, 4, minus 2, minus 4. I have maybe 2, 4, minus 2, minus 4. Please, are you with me?
Yes, madam.
Yes, madam.
Yes, madam.
Okay, so my vertical asymptote is the line s equal to x, s equal to 4, positive 2. So s is equal to 2, and then s equal to minus 2. These are my vertical asymptotes. We realize that there's no horizontal asymptotes, but we have what we call oblique asymptotes, which is the line y is equal to x. When you sketch, it's the line y equal to x is a straight line that passes through the origin. So it's going to be a straight line that will pass through the origin like this. So you can just draw a thick line. So that's my oblique asymptotes. Okay. Then after that, you look at the behavior of the graph as you approach positive 2 from the left, from the right. You look at the behavior of the graph as you approach negative 2 from the left and then from the right. Please, you can get your table, you try to fix some values, and then you see the behavior. Okay, so we go back to the notes. It says that, okay, so here they are finding out if the function is even or odd function. And I don't know if you know what an even function and odd function is. Now, if a function is odd, if a function is even, then f of x should be equal to f of minus x. If f of minus x is equal to f of x, then it means that the function is even. This is an even function. But if f of, so I've interchanged it. If f of minus x is equal to f of x, then it's even. If f of minus x is equal to minus f of x, then it means that the function is an odd function. Please put this one somewhere. If f of minus s is equal to f of x, then the function is even. F of minus s is equal to minus f of x, then the function is odd. Okay, so here they want to find out if the function is odd or even. Okay, so you find f of minus x, you substitute, and you're going to get something like this. So this is the same as minus of f of x. So this means that the function is odd. Hey, now, if a function is odd, then it means that the graph will be symmetrical about the origin. So dividing both the numerator and denominator by leading term of the coefficients. Okay, we divide through by x squared, you're going to get something like this. And this was the remainder that I got. Okay, it looks like the remainder. Okay. So it means that my horizontal, my oblique asymptote is the line y equal to x. Now we have to look at the behavior of the graph as we approach -2 from the left. And please, when you take your time to do the table, you're going to see that the function will approach -infinity. And as we approach -2 from the right, we see that it will approach positive infinity. Then you see the behavior as we approach +2 from the left, that is -infinity. Then approaching +2 from the right will be positive infinity. Okay. Okay, so it says that for the straight line, when s equal to s, y equal to x, so it means that the graph will pass through the origin as I did. Okay, so I have my origin, I have my oblique asymptote. My horizontal asymptote is not showing, but it's supposed to be the line s equal to +2 and s equal to -2. You see that as you approach +2 from the left, this is approaching positive infinity. So approaching +2 from the right, it's approaching positive infinity. So that's what I have here. So on the graph, as you approach it from the right, on the right, you see that this is approaching positive infinity like this. Then it says that when I approach it from the left is approaching -infinity. So I have the origin, then this will approach -infinity like this. Then as you approach -2 from the right, this will approach positive infinity. So this will look like this. Then approaching -2 from the left, this will also approach -infinity. So it will be like this. So the graph will look like this. So please, you can go online and then look at how to sketch graph rational functions. But this is how our graph will look like. You have the points, this intercept. You can also find the x and y intercepts, the function. You find x and y intercepts, you plot, and then you will know the domain. Okay, so that is it. Slant asymptote, that is what I just treated. Okay. So we just did slant asymptotes. That is that. So example, we have a function like this, and we want to find, it says that we should find all the asymptotes. So what will be the vertical asymptote for this function?
-1 out of 3. S equals -1.
Is plus or minus negative. Plus or minus root of 1/3.
Are you sure?
Plus or minus.
Okay, let's find the horizontal. What's the horizontal asymptote?
Madam, Mariam's video is
zero.
Y equal
Madam,
to
y
0.
equals 0.
switch off your camera.
Okay. So y equal to 0 is the horizontal asymptote. Then the vertical asymptote, you have to solve the line 3s squared plus 1 equal to 0. And I'm going to get s squared is equal to -1/3. And s is equal to square root of minus 1. This is not real. Negative square root of negative 1 over 3. And we are in the real plane. So it means that we have no vertical asymptotes. Do you get it? Please, you get it?
Yes, please.
Because we are solving 3x squared minus 1. We have 3x squared minus 1 equal to 0. And this is 3x squared equal to, is it plus 1? It's equal to minus 1. So this is x squared is equal to minus 1 over 3. So my x is square root of minus 1 over 3. And when you punch your calculator, it will say that it will tell you that it is math error, or it does not, it's undefined or something like that. Math error. So since we are in the real plane, this will not exist unless we go to the complex plane. But here we are solving real plane. So it means that there is no vertical asymptotes. If you go to the complex plane, it's possible, but here no vertical asymptotes. So my horizontal asymptote is the line y equal to 0, and then the vertical asymptote is no vertical asymptote. So the graph will look like this. You can have more examples. That's what would be the what would be my horizontal asymptotes?
It's 2.
It's 2.
Y
What will be my
to
y equal to 2? What will be my vertical asymptotes?
S equals plus or minus 1.
Plus or minus.
Okay. Then you should be able to sketch the graph. So you have plus or minus 1. Then you have y equal to 2. Then you look at the behavior as you approach plus or minus 1, either from the left or from the right. You have to plot your s-intercepts and then your y-intercepts to get it. So you have something like this. This one too, you can find the horizontal asymptotes to be 1. Then you can find the vertical asymptotes. Okay. So this one you are solving. Okay, so you see that 2 plus x and 2 plus x is the factor of the top one and then the down one. So you solve, you simplify. So it means that in the domain, x equal to minus 2 cannot be in the domain. Okay. So this one, when you have something like this, you have to try to find the factors for the numerator and the denominator. If there is a factor that is in the numerator and the denominator, that cannot be your vertical asymptotes. So you cancel that one out, and then you choose. You see that there will be 1. So here the vertical asymptote is the line s equal to 2, s equal to 3. Sorry. So you solve. So we are saying that that graph will have a hole at s equal to minus 2. So I think, okay, that is vector first one, analytic geometry. I told you about holes. So it means that it will have a hole at this point. Okay. So you choose the minus 2, then you substitute it into x minus 1, x minus 3. Then you see that you have the corresponding point to be here. Okay, so you find the y-intercept, s-intercept, everything. Then you sketch the graph. So these are all examples. Please, you can take your time to look at them. So we are done with the graph of rational functions. Any question? But you have to read more. Any question? You want to continue to the composition of rational functions to partial fractions? Okay, Michael, your hand is up.
Madam, please, in exams, are you going to draw graph?
Yes, please. You will draw graph. So please go and learn. This one there, this is a poor one. One a poor for you. You will sketch graph.
On the graph sheet.
No, in your note, in the answer sheet, you will not draw it with skill. So it's going to be a sketch.
Una wonfa no di nfa. Oyi bɛ fa.
No, Apollo Shaka Wofa, Owusu Alexander.
So, madam, in the case where my y is equal to 0 as a horizontal axis, how are you going to draw the graph?
So that is the x-axis.
For y.
Okay.
Y equal to 0 is the x-axis, yeah.
Yes, madam.
The line y equal to 0 is the x-axis.
Yes.
Yes, madam.
So that
How
will
are
be
you
your
going to make your
horizontal
dotted
axis.
line?
So you draw broken lines on the x-axis.
Okay.
You understand? You know. Converted a copy.
So please, when you go to those assignments for you, read something small on binomial theory. Something small on binomial theory. And then something small on not in the dorsal. I'm not even done with this. Then I have to do something else. Then I will start with the trig functions. But trig functions, I think I'll send you something. For the trig, we'll look at how to get the angles. And then we'll look at compound angles. We'll look at half angles. We'll look at how to solve some simple angles. So I'll get some simplified notes and then send it to you for the trig. We'll do that. But
Yes, madam.
We'll meet. I am owing you 3 hours. So you look for a time for me so that I will meet you for the 3 hours. But try and finish my decomposition into partial fractions. Also, your hand is up. I have 1 hour.
This is not part of our study, but I would like to know. What is it
Oh,
that this
please, I didn't hear you. I didn't hear what you said.
Yeah, madam.
Well,
Please, I would like to know.
your
This is not part of our studies, but why is it that this third cohort, everything is purely online?
Hey, please, I didn't hear. Come again.
I said this is not part of our studies, but I would like to know why is it that this third cohort, everything is purely online?
Are you sure everything is purely online?
Yes, please. We have not
Please, you have to do your you have to do your research well. Maybe it's your group or where you are, because I know other people are doing face-to-face.
For my group, West Coast Center, we have not gone for any face-to-face.
Where are you coming from?
West Coast.
You are from West Coast. But
yes,
West Coast is supposed to be a face-to-face.
And I'm the course rep too. We have not. So it makes it
West Coast. You are not supposed to be here.
Madam, it's an ICT group.
Yes.
ICT course, not mathematics.
Mathematics West Coast, they are meeting face-to-face, right?
Yes, please. They are meeting face-to-face.
So is the IT?
We contact
ICT,
them. They are doing everything online.
So, madam, please, can I come in? Sorry.
Yeah.
Okay, so before a center will be allocated to online, unless the center has a total number of students more than 20. Okay, so if the total number of students is less than 20, yeah, you'll be pushed to online, whether you like it or not. Okay, so probably that's why your center you are online. Okay.
My guy,
Thank you very much.
20. We are more than 20. IT mathematics.
IT, are you more than 20?
Yes, please. More than 20. IT mathematics, we are more than 20.
For West School?
Yes.
Aye, so you don't want online, you want face to face. What's the difference between face to face and online? Is it
Madam, you
because
want face to face.
is it because the face to face will be playing and doing other
No, you
things
see,
and
the
you are not
face to
able
face,
to
you
follow?
see, a lecturer is, sorry, you see, you'll be writing on the board and you to at least, if there is
But I've
anything,
been writing on the board. Don't I write on the board?
Madam, you do, but you see, at times, like that manual one, you see, that one, we prefer that one more than this one.
Hey, the world is going AI. The world is going AI. We are still looking at news could be.
Madam, you will go, but not now.
Then help us use
Hey,
AI
no,
to
go
answer.
now. Let me know Joseph, your hand is up.
Madam.
Joseph.
Good morning, madam.
Hello, madam. I think it's a
Madam,
wrong
good
hand.
morning.
Sorry. It's a wrong hand.
Yeah, Joseph.
I don't even know how you I don't know.
Please, can you hear me, madam?
Please, you can talk. Yeah, I can hear you.
Please, can you hear me?
I can hear you, Joseph. Yeah, I can hear you, Joseph.
Madam.
Yes.
I have a request to make, please, with regard to the 3 hours you said you are owing us. When you have to face time, please don't make it on school hours because school have reopened, so that time most of us will not be available.
So it can't be next week, Saturday.
Saturday will be possible. I mean, it shouldn't be on school hours.
Okay, so I'll try and fix this maybe next week, Saturday. Even though I'll not be around next week, but I'll see if I can get, I'll be able to teach.
All right.
So
thank you very much.
Yeah, I'll communicate back to you right here. Then Mustafa, to your hand is up.
Madam, good morning.
Yeah, good morning.
Madam, this time the course content for algebra and trigonometry.
I think it's not this time, oh, that is how it has been. I think algebra and trig. Algebra is a broad something, and then trig is also, but I think that I was supposed to pick some few, so I have to look at my notes again, take some things off. But if I do that, it means that you will not get so many things. But still, the next one is the same thing. Even with the regular students, teaching algebra and trig is very difficult because the course is very loaded, and even in the department we have even taken some things off because we used to teach what do you call it, matrices and other things, but we've even taken them off. They are all under algebra, but we've taken them off, but still the notes or the course is still loaded. So we see how best, but you need this. You need everything. So we are sorry, but maybe you have to set up small because you will need them in 102, 202, 203, and that you will need the 101. The trig, even the trig, I'll have to look for some simplified notes and send it to you so that you learn on your own because we will not be able to do that. Please let me continue. I have just an hour and I have to finish with what I have to do, please.
And please, I didn't finish. I was saying that the nature of the course, as you have really said, it's too we are pleading the examination should at least should be
what be exams home.
No, madam,
Madam,
it's true. Madam,
Are you sure? You are going to teach you. You are going to
no,
teach.
you apply after that. You apply. You apply. You learn and
when it comes to the teaching, we can sit down and learn and go and teach. But when it comes to the exams, you see, we have shorter period of time to sit down and then who I write the exam, the probability of failing that one is too. That one also is also.
You not
But
fail.
when it
Then
comes
had
Don't worry, Madam Begu Mama, why? Mama,
Madam, get my dear bank one year pill.
don't worry, I'll give you standard questions. Let's continue. So want to look at decomposition of rational
Get my
functions
dear bank one.
into
Pasco,
partial fractions.
we want Pasco.
So let's continue. Two rational functions can be added, multiplied, divided, and subtracted to obtain another rational function. For example, if I have 2 over x minus 1 squared plus 3 over x into x minus 1, we can add to get 5x minus 3 over x into bracket x minus 1 squared. Okay, so in this session, we consider an important operation in which a rational function is decomposed into its partial fractions. In decomposition, we express complicated rational function as the sum of simple rational functions. Thus, it is process that reverses the operations in the given example. We shall consider 4 cases, so please pay attention. We are considering 4 cases for decomposition. So let f of s be p of x over q of s, where the degree of p of s is less than the degree of q of s. So the first thing you have to look at is the degree of the numerator should be less than the degree of the denominator. In this case, suppose that the denominator q of s can be factorized into non-repeating linear functions. That is, if the degree of q of s is n, then I have p of s divided by q of s is equal to p of s over x minus x a1, x minus a2, up to x minus an. So if I decompose this, so I'm saying that the first thing you have to look at when you are given rational function to decompose, you have to make sure that the degree of the top is less than the degree of the denominator. That is the first thing. Then the next one is the factors. If the factors of q of s are non-repeating linear functions like this, then when you decompose, you can write it as a1 over x minus a1 plus big A2 over x minus small a2 up to big AN over x minus small an. Some people will use the top one, they will use a, b, c, and so on. So it's the same thing, where 1, 2, and 3 are constants. So example, I have 7x plus 11 over x squared plus 2, 3x minus 2 plus 2. And I want to decompose this one into a partial fraction. So it says that I have to look at the degree of the numerator and the degree of the denominator. Here, the degree of the numerator is 1, the degree of the denominator is 2. So the degree of the numerator is less than the degree of the denominator. So that's one is satisfied. Then I have to look for the factors of the denominator. So there's a quadratic function. I should be able to find the factors. When I find the factors, I'm going to get s plus 1, s plus 2. And we can see that they are non-repeating linear functions. S plus 1 and s plus 2, they are not repeating. They are not the same. So in that case, my function, when I decompose, I'm going to get a over s plus 1 plus b over s plus 2. That's like that. Then after getting this, I have to find the value of a and then the value of b. And to do that, I will multiply the left and then the right by x plus 1, s plus 2. Okay, so I'll multiply this by x plus 1, s plus 2. I'll multiply this by x plus 1, s plus 2. I'll multiply this by x plus 1, s plus 2. When I do that and simplify, I'm going to get 7x plus 11 is equal to a into s plus 2 plus b into s plus 1. I want to find the values of a and b. Now, if I choose my x to be -1, then I have b into brackets minus 1 plus 1. So that will take care of my b. So first one, I'll choose when s equal to -1. When x equal to -1, this will be -7 plus 11, which is 4. So I'll have 4 here. Then this one will be A into minus 1 plus 1 plus 2, which will be 1. So this means that my A will be equal to 4. Then the next one, I want to get rid of B. So I'll choose S equal to 2, negative 2. When S equal to negative 2, this one will go to 0. Then this will be minus 14 plus 11, which will be minus 3. And this one I have minus 2 plus 1, which is minus 1. So this will be minus B. So I have minus B is equal to minus 3. So my B is positive 3. So I go back. My A is 4. My B is 3. So I go back and the function will be 4 over S plus 1 and then plus 3 over S plus 2. So I've been able to decompose it into partial fraction. It says that note that in the example above, the value of X chosen to obtain the value of A and B are not determined arbitrarily. They were chosen to make sure of the term in the right equals to 0. So that's one way of solving, finding my A and B. Now there's another way of finding my A and B, and the other way, that is the alternative approach. The alternative approach, I have 7S plus 11, then I will open up this bracket. So when I open this, I'm going to get AS plus 2A plus BS plus 2 plus B plus B, which will be, so I have AS BX, so I can write it as, let me write the alternative approach. Graph, learn the graph.
Madam, quiz no, madam, I don't know why I'm kakran because block 1 on the name is the crowd, madam. Quiz there.
What be who bring ontology?
Madam, the graph, which one?
Everything I mean, learn how to sketch rational function in graph. Okay, so the second alternative, I have 7x plus 11 is equal to A into S plus 2 plus B into S plus 1. Okay, so to use the second alternative, this is 7s plus 11 is equal to AX plus 2A plus BS plus B. This is the same as 7x plus 11 is equal to, so I have AS, BS, so I have A plus B, then I'll bring the S out, then I have 2A plus B like this. So what the second alternative, what it says is, I'll compare, this has 7 has X, this has X. So I will write 7 is equal to A plus B. Then I'll call it equation 1. Then I see that this is a constant, this is a constant. So I'll have 11 is equal to 2A plus B. I'll call this one equation 2. Then I want to solve for my A and B. So I will solve the two simultaneously. So I can subtract equation 1. So subtract equation 1 from equation 2. So equation 2 minus equation 1. This will give me 3. This is equal to minus, when I subtract this, I'm going to get A. And when I subtract it, I'm going to get 0. So this means that my A is equal to 3. Now I can substitute A is equal to 3 into equation 1. So put A equal to 3 into
7 is 4.
Equation 1. It's 4, eh? Sorry. It's 4.
Yeah, A is 4.
Okay, so I want to substitute S equal to 4 into equation 1. So I have 7 is equal to 4 plus B. So this means that my B is equal to 3. So I've been able to get my A to be 4 and then my B to be 3. So I go back and do the substitution. The function was
This
So I have 7x plus 11 over x plus 1 plus 2 is equal to, so 4 over, was 4 over what? 4 over x minus plus 1, and then 3 over x plus 2. So that's what I'm going to get. Okay.
Questions like this is very, very good.
So you can use this second approach and you're going to get the same thing.
I'm wired. You read them.
Oh, wait, dear, wait, dear.
Madam, wait there. Akoyi papa.
Bibi say bipa de madam no mo na be.
Madam, you could pay ya. You could pay ya. Embla say ya.
Yeah, we be try.
That way, you know, but I feel as a my idea.
Madam, why you need that? But wait there, exceptional. So you super fantabluta.
Where you from? Bruce.
Mama, where you fan fala?
Okay, let's continue.
Yes, madam, where you guys?
So the case 2, we are done with the case 1. The case 2, we have to make sure that the degree of P of S is less than the degree of Q of S. Now, in this case, suppose that the denominator can be factorized into repeating linear factors. So here we can find the factors to be repeated, like this, x minus a to the power n, or maybe to the power 2 or something. If it's like that, then when I write it, decompose it, I have P of x over x minus a to the power n equal to a1 x minus a plus a2 x minus a to the power 2 up to an x minus a to the power n, where i's are constants. So example is this. I want to express this as a partial fraction. So looking at this is squared. So this means that x is to the power 2 times this is to the power 3. So the numerator has the power 1, the denominator has the power 3. So it's fine. First condition satisfied. Then the second condition. The second condition, I can write the first one as a over x minus 1. So this one is a combination of the first and then the second case. So the first case, I can write it as a over x minus 3. Then I have the x plus 2 squared here. So that one, I'll write it as b over s plus 2 plus c over s plus 2 to the power 2. So the second part, the second case here is what I'm applying for the s plus 2. I have to write the x plus 2 itself, then s plus 2 squared. If it is to the power 3, then I have s plus 2, so I'll have maybe b over s plus 2, then c over s plus 2 squared, and then maybe d over s plus 2 to the power 3. So that's how it works. So if I have it like this, then the factors will be this. So I have to multiply through by x minus 2, x minus 3, s plus 2 to the power 3. So when I do that, then the left-hand side, I'll be left with 3s plus 1 is equal to, then this side, I'll be left with a into s plus 2 squared. And this side, I'll be left with b into x minus 3 times x plus b. And the c side will be left with only x minus 1. And this one, I have to find the values of a and b. So you can use the first method where you can choose s equal to 3. When s equal to 3, my c will die, it will go to 0. My b will also go to 0. Then I can get the value of my a. Do you agree?
Go over, please, madam.
Yes, madam. Yes, please.
Yes, madam. Yeah.
I'm saying that you want to find the value of a, b, c. So the first thing I will go to the c and see that when s equal to 3, when I substitute 3 here, this will be 3 minus 3. So this will go to 0. Then when I substitute 3 here, B2, I'll have 3 minus 3 go to 0. So when S equal to 3, both my B and C will go to 0. So I'll have 9 plus 1, which is 10, is equal to A into 3. 3 plus 2, which is 5. 5 squared is 25. So I solve for my A, and my A will be 10 over 25. So my A is 10 over 25, which is 2 and 3. Then I can come back and look for another value. When S equal to minus 2, when S equal to minus 2, A will go to 0. My B will go to 0. Please, do you agree?
Yes, please.
Yes.
My A
No,
will
you
go to
said
0.
minus 2.
Minus 2, my A will go
Yes,
to
it's
0.
minus 2.
Yes.
My B will
So
also
A
go
will
to
be
0.
0.
Then B2 will go to 0. So I can find my C. So when I do that, my C will be equal to 1.
Madam, this one is mathematical IO.
So I'm left to, I have to find my C, my B. To find my B, I can expand everything. So when I expand, I'm going to get this. Then I can get equations. I'll compare coefficients. When I look to the right, I don't have any S squared on the left. So it means that I'm going to get A plus B is equal to 0. Please, can you see that? On the left, I have 3S plus 1. I want to compare coefficients, but on the left, there's no S squared term here. So it means that my left can be written as, instead of writing,
Let's use the slides.
I should use the slides.
Yeah, let's use it. Let's use it.
Hey, Charlie, people understand sense. I have 3x plus
Yeah, Michael gets
1
you.
is
Michael
equal
gets
to
you.
A plus B.
You don't worry, I'll get them.
S squared something. So when I compare this one, I can write it as 0S squared plus 3x plus 1 is equal to A plus B S squared, then plus the rest. So when I compare, I can say that A plus B is equal to 0. So I have A plus B equal to 0. But I already know the value of A. The value of A is, what's the value of A?
-2.
You are lying. So the value of A,
Are you sure?
10 over 25, which is the same as
Yes.
2 on 5.
Yes.
So it means that my B will be equal to minus 2 on 5. So that is my B. 10-1, first step, I've gotten my B. So my B is minus 2 on 5. So I can now write the partial fraction. My A is 5 on 2. So I have 5 on 2, x minus 3, minus my B is negative 2 on 5. So I have minus 2 on 5, x plus 2, then plus my C is 1. So I have 1 over x plus 2. That is it. So you have some examples here. You can decompose them. Are you okay?
Yes, please.
More than okay.
Hey, Charlie.
Madam, this particular topic, I think this one is on track.
Madam, take 4 of these questions and 1 of the graph. That's all.
Oh, it's true, madam. Hey, this one, drop this one for session B. Plus the
Don't mind
Michael, you go to heaven. You, Michael, you go to heaven.
I did 52 and I may course. Look at it.
Madam is tired. Let's have wrap it up and go in.
Madam, thank you very much. You understand me. Women understand women. Women, they understand women.
He's a man.
Madam, I'm a boy. I'm a man.
He's a married man, that's why.
He's a married man. You've done well.
We don't think about madam. Thank you.
Yeah, but for there.
You understand your words. You've done
Give your
well.
game.
Let's continue.
Manu,
So we are
Manu,
on the
thank
case
you.
3. The case 3.
Manu,
Still,
Manu,
you have, hey, Charlie, I'm talking to
Manu, thank you.
for the case 3 too, you still have to look at the degree of the numerator and then the degree of the denominator. Now, if the degree of the numerator is less than the degree of the denominator, is fine. So that one should be satisfied. Then you have to look at the factors of the numerator. Now, if the factors of the numerator are written as quadratic function, maybe quadratic function, where the discriminants, so this one we don't, where the discriminant is less than 0. So where the factors are imaginary. So if the factors of the quadratic equation are imaginary like this, then decomposing it will be a1x plus b over the first quadratic function plus a2s plus b2 divided by the second quadratic function. I mean quadratic function that has its root to be imaginary, that the discriminant is less than 0. If you can decompose it, then you decompose it and use the first approach. But if you cannot, I mean, if you can find the factors, then you find the factors and use the first approach. If you cannot find the factors, then you use this approach. So example, it says that express f of s is equal to 3 minus x over s to the power 3 plus 1 as a partial fraction. So here the degree of the numerator is 1, the degree of the denominator is 3. So it's fine, I can decompose it straight up. So what I have to do is to find the factors. Let's try and find the factors of this. So you can see that s equal to -1. S equal to -1 is one of the factors. So you use long division or any approach to divide this. When you divide, you're going to get the factors to be x plus 1, which is the first factor that you found. And the next one will be x squared minus x plus 1. This, let's find the discriminants. The discriminant is b squared minus 4ac. So I have minus 1 squared minus 4, a minus 1, and then c. So minus 1 squared, it will give me positive 1, minus 4 will give me -1. So this is less than 0. So this means that this thing here has imaginary roots. So to decompose this, the first one, this one will first take the first approach. So I have a over s plus 1, then plus, because this one is a quadratic, I have bs plus c over s squared minus s plus 1. So that's what I have. Then I have to solve my ABC. So I multiply through by the denominator here. So this one will be 3 minus s is equal to, please excuse me.
Jeremiah, on Sabbath you, on Sabbath or nothing is that you.
So I expand, I'm going to get a into s squared minus s plus 1, and this will give me bs plus c into x plus 1. Okay, so when s equal to -1, this side will go to 0. So when s equal to -1, this will go to 0. Then this will give me 4. I can solve this. This will give me 3. So my A will give me 4 on 3. You have A equal to 4 on 3. You can expand this. When you expand, you are going to get A plus B times S squared plus B plus C minus A. I think I didn't write it well. So that would multiply X. Please, you can expand this. We have okay, so let me see. So when I expand, I'm going to get it's A times S squared minus, so A times S squared minus X minus 1, then plus BS plus C multiplying X minus 1, S plus 1, S plus 1, and this side is 3 minus X, so 3 minus X. So when I expand, I'm going to get AX squared minus AX minus A plus BX squared plus BX plus CX plus C. So this will give me BA plus B squared plus into brackets B plus C minus AX like this, then plus I have C minus A. So when I compare the coefficients, I can see that A plus B is equal to 0. That's equation 1. Then I have B plus C minus A is equal to minus 1. I'm comparing this to this, so this minus 1. Then I have C minus A is equal to 3. Okay. So what do we have? We've been able to find A. Okay. So my A is 4 on 3. So that means that my B is minus 4 on 3. Then I have A plus C equal to 3. So it means that I can find C. My C will be 3 minus 4 on 3, which is 5 on 3. So when I write it again, I'm going to get my A is 4 on 3, all divided by S plus 1, plus my B is minus 4 on 3. Then I multiply it by S plus my C is 5 on 3, which is the same as 4 over 3 S plus 1 plus. So because this is negative, I want to bring the 5 first. So I have 5 minus 4x or divided by 3 into that. So that's it. Please, are you okay?
Yeah.
Madam,
Hello.
madam,
Yes, please.
with this question, at the beginning, 3 minus S all over S plus 1, that is all over S cubed plus 1. I learned in partial fraction, you use the division when the exponent of the numerator is greater than the exponent of the denominator. Is that not it?
Yeah.
But this one, you can see that the exponent of the numerator is less than the exponent of the denominator, and you made mention of division to get.
No, we want to find the factors. I said we should want to find the factors of S cubed. So that's what I said. You can use the long division, use to get the factor theory.
Okay,
to
okay,
find to get the factors.
okay. Thank you.
You're welcome. So that's also an example. This one we have two functions. So this one we can apply the root 2 where the factors will be a over s plus 1 plus b over s plus 1 squared. Then we can see that this is a quadratic function which has discriminant less than 0. So this one will have a cs plus d over s plus 1. So this one is a combination of root 3 and root 4. Because the root 3, I have to do this, then the next one will be the square. So I have s squared plus 1 plus ex plus f over s squared plus 1 all squared. And this one, you should be able to find your a, b, c, d, e. So that is it. You can take your time and solve this. And you get the values. Please take your time and do it. So are we done? Did we say how many rules have we looked at so far? 4, 3. Did you say we'll look at 3 or 4? Okay, so that is the end.
You said 4.
And so where's the 4th one? So maybe 3. So we've done 3. I didn't. Yes. Somebody called you. Okay, so I want to look at translation of functions. So if I have f of x be a function and my c is greater than 0, then I have the following translations. Anytime I have f of x and then I write f of x minus a, this is a translation of my f of x a unit to the right. If I have f of x, then I write f of x plus a. This is a translation of f of x, a unit to the left. So please take note, if it is minus to the right, positive to the right, left. Now, if I have f of x, the function itself plus a, this is a unit up. The function itself minus a is a unit down. So let's assume I have a function like this. So let's assume I have a function like f of x is equal to x squared. We know the graph of this function is this, right? Hello?
Yes.
Yes.
So if I write f of x plus 2, this is x squared plus 2. And it says that this is 2 units to the left. This is 2 units to the left. That is what it says. If it is plus, it is 2 units to the left. So it means that the graph of this function will be, so I have 2 here. So it now has this. So it is 2 units to the left. So the turning point will shift from 0 to 2, negative 2. If I have f of x minus 2, this is x squared minus 2. It says that it is 2 units to the right. So it is the same function, but 2 units to the right. So I'll have this to the right. Then it says that if it is f of x plus 2, so the 2, I'm not adding it to the s, I'm adding it to the function. It says that this is 2 units up. So it will be the original function. Then it will move, the turning point will move up like this. Then I have f of x minus 2. This is 2 units down. So this will be, so I'll have negative 2. So it will now turn like this. So 2 units down. So that's what it means. So it says that this will be 2 units up, and this is 2 units down. And then f of x over 2, so this will over c, this will be a shrink in the s direction. So let's assume this is 2x, then I have f of x over 2. So this will be 2x over 2. So there will be a shrink. Okay. And then when I have c times x, then this will be a stretch. So it means that the function will stretch it to expand. Then if I have c of f of x, it means that it's a stretch in the y direction. So it means that my y function will stretch. And then if I have 1 over c times f of x, it means that it is a shrink. Then if I have f of x, f of negative x, we are saying that this is a reflection of x in the y-axis, and a negative f of x is a reflection of f of x in the x-axis. We can look at examples. Okay, so this one, we want to sketch the graph of the function f of x is equal to 1 over x. This is a rational function. So to sketch this, I have to find my horizontal asymptotes, vertical asymptotes. So what's the vertical asymptote for this?
Zero.
Yeah, hello, I'm here.
Adam, 0. S equal 0.
So the line s equal to 0 is my vertical asymptote. That is the y-axis. What about my horizontal asymptotes?
I want y equals 0.
So y equal to 0, my x-axis is my horizontal asymptote. Then you have to look at the behavior of the graph as you approach 0, either from the right or from the left. So the graph will look like this. So as you approach 0 from the right, it will approach positive infinity. As you approach 0 from the left, it will approach positive infinity. So the graph will look like this. Now let's see. It says that deduce 1 over s plus 2. So this means that I have s plus 2. So this means that my function is moving. What does it mean? Is it moving? It's moving 2 units to the, is it right or left?
Adam, left.
It means that the graph will move 2 units to the left. So now my vertical asymptote will be the line s equal to negative 2. Then I have minus 3. What does this mean?
3 step up, downward.
Okay, so it means that it will move 3 steps downwards. So now the graph will move 2 units to the left. So my horizontal asymptote is now this. Sorry, vertical asymptote is now this. Then it will move 3 units downwards like this. So the graph will now look like this. Or you can also find it's the same as finding the vertical asymptote. So here the vertical asymptote is the line s equal to minus 3. And then the horizontal asymptote, this will go to 0, but this will be negative 3. So your horizontal asymptote will be the line y equal to negative 3. Okay, so it says that s equal to 0 is a vertical asymptote, and then s approaches positive infinity as y approaches 0. Therefore, y is equal to 0. It's a horizontal asymptote. And as s approaches 0 from the left, y approaches negative infinity. As s approaches this from the right, I think we didn't write it well. This will approach positive infinity. So the graph is going to be like this. So you are just using translation. It's moving 2 units to the left and then 3 units down. That is it. Okay, so that's the next one. They are saying that this is s plus 2. So this 1 over 2. 1 over s plus, that's and then the minus 3. So it means that I have f of s plus 2 minus 3. That's g of s is a translation of f of s, 2 units to the left and 3 units down. So it's the same as by the translation vector -2, -3 from SHS. So this thing here is the same as by translation vector -2, -3, JHS. So alternative approach, you divide, you use the long process to get that. So next time we want to look at absolute functions and functions involving radicals. So we know that we recall that if y is equal to absolute of x, it's the same as we will have s as when s is greater or equal to 0, then you have negative s when s equal to less than 0. So the graph, I think I drew this one for you. The graph of y is equal to absolute x is this. Then for this, we can also add, and then, so if I have f of s equal to absolute of x plus 1, what does that mean? Please, what's the meaning of A?
It moves upward.
Okay, so it means this, it means that this graph will move 1 unit upwards. What about the second one?
It will move to the left.
So it means that the graph will move
1
1
unit.
unit to the left. Okay. So the first one, we're going to write this. This is x plus 1 when s is greater than 0, or minus s plus 1 when s is less than 0. So as you said that the graph will move 1 unit upwards. And then the second one, we have s plus 1 as s plus 1 is greater or equal to 0, or s is greater or equal to 1, and then you have minus x minus 1 as s plus 1 is less than 0, so you have s less than 0. So as you said, it will move 1 unit to the left, so this is supposed to be minus 1. So you have some questions here, you can look at them. I still have 10 minutes. So we come to the end of this first notes. Then let me see, I think I have, you have the other notes, right?
No, madam.
Hey, is it not in the group?
Madam is there.
No, madam.
But that maritime mathematics, they don't have it.
Okay, so let me copy, let me look at my own notes. So my notes. I see, matter. If you don't have it, please contact your other friends. And please, if you are on the group too, you can share it on the platform.
My colleagues, kindly share it on the switch group for us to download it.
Unless you're for I'll share to you personally.
People are bad, though. You share with somebody personally. What about the rest?
So I'll send
Madam is in
Put it in the platform so that all of us will have
He's
it.
from West.
I'll do Charlie, guys, I hope you see what I'm seeing.
What are you saying?
You can't see what we are seeing.
I see analytic geometry quiz questions.
So you want to steal from me? This is past questions. Don't worry.
No, I'm not saying I want to see, but if you can open it for
And
me.
that's all the things here are 2024.
Madam, please share the passcode.
Here, please, I will share it. I will share it later.
Hello, madam.
Madam.
That will do all.
Madam, please, I want some clarification. In sketching the graph, when you are sketching it, the coordinates, the S and Y coordinate, are you to indicate it, or you just do some marking and then maybe you draw the graph, or you are supposed to indicate the coordinate?
S and Y coordinates, Ben.
Now, when you are sketching it, maybe You get your vertical system and then the horizontal one. You are supposed to get some points to draw it, sketches. I don't know.
You
if I'm
have
supposed
to plot the points.
But since we are going to just sketches, how accurate can that be?
How what?
Because we are not going to provide us with graph books. How do we do that?
So it's just a sketch. So you try to locate something, but it should be nice.
Okay. All right. Thank you.
Welcome. Yeah, I can't find the continuation of the note. Where is it? It should be somewhere. Week 4. Where's my?
There are other alternatives.
It's week 4 to 5.
Do you have it? Please send it to me.
Okay.
Yes, please.
Share it on the platform right now so that we continue. Is it there?
Yes, madam, I've shared.
Hey, how come I cannot see it? On the platform? Oh, I'm not on the platform. Okay, it's
Maybe
here.
probably it's on the okay.
Hey, this course outline you, uncle.
Oh.
It's still course outline.
Again.
Madam, by it merge.
Madam, it is a merge one.